So, hello everybody. So my name is Hendrik and this is my colleague Hilko. We are working together in how the name of our talk is, in a large enterprise. Whatever that means, so we have a lot of systems. Hilko?
Well, my background is in security contexts in several ways. For the last 5 or so years, I've been part of CISO of a large company in the transportation space, and have been a colleague of Hendrik's, and
Yeah. So, and my background is I'm coming from offensive security. So I've never been a speaker here, but at some other conferences, and I also have a background in anomaly detection. So that's at some point of time I decided to go to a blue team, some new challenges, bring my knowledge into. And then I learned to know Hilko in the same team, and we had some decisions to make. So we had the task to set up a security monitoring for Linux systems. And with both of our backgrounds, so it's an interesting combination, I would say. So the one is writing detections, and the other one has good knowledge in developing tools. So we decided to make some customizations, and that's in a quite large enterprise. What large means? When I'm talking about large, I'm saying it's more than 10,000 systems, servers. So only Linux systems here in our scope. Sure, there are also Windows systems, but we are searching for a solution to have a security monitoring in Linux.
In our case, it's more Linux systems than Windows systems.
Yeah,
by
nowadays. So
a factor of 3 or 4.
Quite a lot. And more than 100,000 clients which are connecting to that servers and doing stuff. So due to all those connections and usage there, we have a lot of data. So if you take a look to the normal operating system data, what's happening there, so executed files, network events, and so on, it's quite a large amount. And if you then also take a look to web server logs or whatever, you are in an area of petabytes. So a lot. And that also means we had some more challenges in a large enterprise. You usually you don't know all the 10,000 systems. So there are a lot of systems. We have to establish security monitoring, and you don't know all of them. So yes, there is an asset management where people just scribe some stuff inside, but usually it's already outdated when it's filled in, right? So everybody of you knows it, I think so. It's a typical problem. There are also technologies in place which are old, which are new. So we have a lot of different kernel versions, distributions running, and we have to find a solution more or less for all of them. Nevertheless, there are also some dynamic systems. So, of course, we have cloud. Of course, we have containers. So there are systems coming up and going down all the time. And at least for those systems, we don't have an up-to-date management system because they are just running for some hours, for example. All that out-of-scale stuff. The next, I would say, challenge for large enterprises are also regulations. So the typical word everybody knows working in such areas is EU tender. So if we are buying a product, we have to think months or years in future. So it's all about money. So if we buy stuff, we have to make a tender, and we have to define exactly what we need and what do we want to buy. And sometimes, especially in that dynamic Linux environment, tomorrow there is a new technology, it's not working that well. And that's why we want to share our experience with you.
Yeah, knowing what we want or what we want to buy or build is a challenge in itself. And at least our experience has been when you build it yourself, you learn along the way what you want. So that's maybe an argument for doing it yourself. So I trust that you are familiar with the incident responders hierarchy of need. At the base, you kind of have to know your environment. You have to be able to gather basic system information, asset information, have an inventory of stuff that you want to keep sure. As Hendrik alluded, the classic centralized asset management tools fail us in several ways. Because the environment has gotten far too dynamic, and often the information is incomplete or outdated. But we'll come back to that later. Then we'll have to build some sort of telemetry on which to build detections. And finally, if we actually find something that's suspicious, we have to be able to act on it, to gather context, and to, if it's a legit alert, to counteract the threat. And the orangish, reddish top of the pyramid. This is not mass business, so that's what happens if you really have a serious incident. There are no pre-made playbooks or automation for that, as far as I know, at least.
Maybe you should say we are just focusing on the technical side. Some processes, tracking, and so on is not part of this talk.
Right. So for the detection. In the beginning, we had, for the Linux systems, we had audit rules in place, which produced massive amounts of log files that we ingested into Splunk, and which were not really useful. More of that in a minute. So I wrote some post-processing tool that turns the audit logs that are not workable in a scene context into something that we could work with. The output format is JSON-based, and we added some capabilities to track parent-child relationships and label processes. So this is what the log format looked before. I've added some some line breaks here and there, but this is just one event, a fictitious attacker running a reverse shell, a Perl-based reverse shell. As you can see, you see that it's a Perl process, but you don't get to see the entire program that's being passed as part of the command line. And the reason why this is all hex encoded is that there are the audit format is simplistic in nature, so it's easy to write post-processing for that, but it's not really fit for purpose to do security monitoring based on it as is. So after post-processing it with Laurel, which is happening on the endpoint, we get to see the command line that is actually being run by Perl, and it doesn't take much to recognize that this is, if you've seen this stuff before, that this is a reverse shell, and you can even get to search for IP addresses and such. So this is much more useful to go hunting for or to write rules for. There's another thing that I want to point out. So this is a fictitious example, but the Perl process has been labeled with WebLogic, as you can see in the. Do I have a mouse cursor? Yeah, I do. There's this label WebLogic that has been added by Laurel based on a rule we have provided in the configuration file. So the Laurel observed that the WebLogic process through other processes at some point spawned this reverse shell. So this is very useful to detect weird stuff being spawned from web application services and such. And this has helped a lot. Well, this is a slide that points out how all the machinery works. Linux audit subsystem runs in the kernel, produces those text-based events I showed you before. Those are then processed by the audit daemon. The audit daemon usually writes its own messy log files that are basically what it was given by the kernel, more or less. All this happens in response to a rule set that you have to configure. For instance, we have it configured to log every program execution, execve, and some other interesting things which I won't go into now. But, in our case, audit also passes the events onto Laurel that does its post-processing based on the configuration we also provide. At some point, well, I have the feeling this happens every few years that we get asked to look at EDR products. The last time we did this, it didn't give us good results. The vendor's view is, well, we have a detection stage, the D part of EDR. Well, we log telemetry and have some detection, whether the detection happens on the endpoint and leads to maybe blocking events, or if it happens in the back end. That's up to the vendor, and as a user, you don't really get to see much of the details on how this is happening. You have to basically do some sort of reverse engineering in order to understand what you are basing your security decisions on. And then there's the response part, which in most cases that we have seen boils down to giving you a shell on the system and maybe some simpler abstracted capabilities based on that shell access. And well, as I said, the products are usually kind of black box products, and we noticed that almost all of them have a Windows first focus. No, all of them have a Windows first focus, and little to no understanding of Unix platforms. For instance, we've seen nonsense like the root account, which is UID 0, being assigned an SID that the EDR just made up. I think it was S1518 or something, which makes sense in a Windows environment, but did not make sense make any sense here. Fork and exec are not understood by all systems that we looked at, and yeah, it was not really pleasant to work with. And it was the systems we looked at also didn't have capabilities or good capabilities to write custom detections in. So in the end, we decided that our homegrown solution yielded much better results, and I still stand by that sentiment. And what we didn't have at the time when we last looked at EDRs was something for the R part, the response part, and we thought that, well, buying an EDR just for the response part wouldn't really have cut it, because we would have had to leave our own solution in place to be able to detect things that really interested us. And running both systems side by side, we kind of saw that as a problem, because CPU overhead, memory overhead for both systems on the same machine was something we are not really prepared to defend against our colleagues that have to do IT operations. We looked at a couple of systems, most notably OS Query and Velociraptor, and in the end we decided to go with Velociraptor as an incident response tool just for the Linux platform, just for Linux server platforms, that is. And it's a great system. Basically, jokingly, you could say it's C2 for the good guys. And with great power comes great responsibility and such. but I think the same would have gone for commercial EDR products. We don't use it only for incident cleanup, but we run Velociraptor clients on all the server systems, and we had to write Velociraptor, as you may know, is very extensible through its own query language, VQL, which is a bit quirky to say the least. Some examples are coming. It's not really easy to debug, but support from Mike Cohen, the main author, has been great, and there's definitely some assembly required. We are using it not as a single monolithic server, but as a distributed systems that's comprised of master and many minions, which comes with its own problems. But Mike has been great to respond to the problems we have run into, and he's been great with merging contributions that we've made, and so this has been all in all, this has been a pleasant experience. So I would like to say a big thanks to Mike Cohen for that. The master's minion setup looks a bit like this. The client connects to a TCP load balancer, which is not part of Velociraptor, but in our case, AWS infrastructure. And the TCP, the encrypted and authenticated TCP connections, I think it's gRPC, they are forwarded as is to either the Velociraptor master or the minions. And they talk amongst themselves, and they share. They have a big shared state as in the form of a large NFS storage. And we have found that this has been kind of a bottleneck, which we are still struggling with. So the connections from the master and the minion back to the NFS, that has been a bit problematic, but it has improved. So what else to say about this?
Yeah, I mean, that setup is more or less scalable. So if you have some more clients coming up, it's no problem. We just spawn some new minions. Also, we have some separations, as you see. So we can separate between the network where the clients are coming to. So we are not sharing everything, and also can use load balancers and filter traffic, whatever. So it's quite scalable for us. So we decided to use that one. Yeah. Good. So that is just the Velociraptor setup, and the one Hilko explained before was our logging setup. So the just raw logs which are on the system. So as you see, we just wanted to stay as raw as possible because nobody's lying at us. All the EDRs are all sampling and so on. So maybe we are missing some events, and so with that solution, we have exactly what's happening on the machine. But in the whole enterprise setup, we have some more devices, we have some more requirements, and some more tools running up. One of the tools, of course, is a SIEM. So we have one central cluster where we are correlating events, and we have to process the events. So all the Laurel output will be sent to the SIEM, and of course, based on the alarms or whatever happens in the SIEM, we have a source, so some kind of automation behind, where things will happen. So an analyst will be notified, or just some automatic investigations will happen on the machines to get some further information. And that's where the connection to Velociraptor comes into the game. The ZOR also now has access to something to do investigations and response. That's also what all the EDR vendors are advertising. So that's what they can do. And with this combination, we are also exactly in that situation to do so. Over the years, we built a lot of artifacts to do so. So it's now a good part of our ecosystem, and it's really scaling. So up to 10 to 20,000 systems. It's working. It's just now a question of how much hardware you are putting into it. Good. But let's take a closer look to Velociraptor itself. I mean, it's made for response, or for triage, but it has all mechanisms to do more of it. And as we said, asset management is key, or at least to have a kind of identification what is running on the server. So the whole asset management thing also means that that we have to that we have people where we can contact. That data collection just collects data. So it means which package is installed, what ports are opened, services which are running. And based on that, we can label systems. So all the systems running there has some kind of label. So it's called in Velociraptor. It's just information. And based on that information, we can now do auto investigations, search for IRCs specific for that, check the integrity if everything is running as expected, or do some more stuff. So there is a server event, client event, that's called in Velociraptor. You can schedule artifacts on demand, or it's just tracking changes on the system itself. Let's jump through the next slides. We will publish the slides afterwards, so you see some more what's the idea behind. And we also can do Yara scans. So we can also do signature scans and behavioral scans with Velociraptor. So there are modules you can implement to do so. So we can go really targeted on what we've seen in Laurel. Good. One more challenge was we have a high rotation. So a lot of systems, like in the cloud, 10,000 system is not 10,000 system, it's 100,000 systems, because they are just spawning and they are going again. So also there, in our changes, we had to talk to the developer how to deal with that. So thanks again. He really implemented a lot of stuff together with us. And now it's quite working for such environments. Good. Just a short summary and outlook. So we learned a lot in that project, and really can recommend if you're going with Linux, all that open source area. It's a way, but it's really important that also the companies, so the enterprises, just are doing it, trying it, and that they contribute. Because all the developers from that project, also Velociraptor, they don't have that capability to do that. So they don't have the experience of enterprises. They have special needs. That's how it's working. But they can do it. That's not a problem. And as a short outlook, I would also say that we are using Velociraptor in a way that Mike never imagined, because incident response engagements are normally short in nature, maybe over half a year. Maybe somebody might be laughing, I don't know. But there's limited time, and we are playing with different rules while we have to clean up the system on a regular basis, or have automated tasks that cleans up old stuff that we don't need anymore. So, but it has not been really been a problem. No. So there's always a solution. You just have to contribute. Yeah. And as Outlook, we are focusing the eBPF now. So all the sensors will in future also use eBPF. And yes, we are working on publishing it. Some parts are already published, like Laurel. Also some artifacts are pushed into the exchange of Velociraptor, and some more will come over time. Okay. Take a look to the times. Thank you.
So the slides are not published yet, but they will be at this address later this afternoon. And if you have questions that you don't want to ask now, you can contact us, and we will be happy to help. And
you're around later?
Yeah. I'll be here till Friday.
I have to leave this evening, but...
All right. Do we have a question or two? No. Well, thanks a lot, guys.
Thanks for having me.